small talk and
all right.
until for a couple of minutes while people join.
Okay, sounds
And
good.
then Navati will share her screen, give an introduction. You can speak for a while, and then I'll move everyone over and we'll have some workshop.
Sounds good.
I'm gonna send a bunch of emojis to our Slack. Are either of you traveling over Christmas or over the winter break?
Christmas, yes. I'm going, well, I'm not traveling for Christmas. I'm just going to visit, going to Pennsylvania to visit family, stay over there, most likely for a couple of days, and just back to Jersey City. That's the plan. But good thing we're not going to be taking any planes. We're just going to be driving, which is easy.
That is a lot easier.
Yes, and no need to worry about anything. So that's the plan for us. How about you guys?
I'll just be here in Cincinnati, living my best life.
I'm just gonna try and keep warm. Yeah. That's it.
True that. I think I might rearrange my furniture in my house. Those are like my big life plans right now. I have a very like long, skinny living room, and it's not very functional right now. And so I've been brainstorming ways to move my furniture around to make it more useful.
Yep, I have actually moved into a new apartment 2 weeks ago, or right before the Thanksgiving. So I still have a lot of stuff to unpack, and they're down there waiting for me to get unpacked.
I'm gonna say moving is the worst.
That is true. So
I would
much.
like to never move again. I have so much stuff.
The funny case is that like it's been 3 years since I moved last time, and it is insane how much unnecessary stuff you can accumulate within the 3 years. It's insane. And I was looking down and I was like, most of the time when I was packing up, it was all about just making sure I'm just throwing away the stuff. That was
I try very hard to throw away everything I possibly can, or give it away.
Yeah.
And give away a lot of stuff to my younger sister, who's recently moved, not recently, I guess anymore, has been in her first apartment for a year now. And
oh wow, that's awesome.
Great place to recycle all my stuff for my first apartment. Navati's going strong in the chat. I love it. Welcome everyone. I know we're just up here making small talk.
Yep.
Yeah. Jersey City. I'm in Cincinnati.
Hi everyone.
Oh, I only did the host and panelist.
Yeah, I was doing that initially.
Ooh, Toronto, Cincinnati.
I think that we can probably go ahead and get started with the intro slides.
Right.
While folks continue to join. Oh, Alex is here. I just saw you on our other call. You have as busy evening of Zoom calls as I do. Do I need to give you permissions? No.
No, I think I'm good. I'm
Okay.
just checking something quickly.
For sure.
Mm. Okay. Cool. So you can see my screen, guys?
Yep.
Yeah, okay, great. All right. So thank you for joining us for today's talk on MVI, Most Valuable Architecture Idea by Aida. And before I get started on our presentation, I'd like to go over our mission, our vision, and code of conduct. So our mission is inspiring women to excel in technology careers. And our vision is a world where diverse women are better represented as engineers and tech leaders. All of our events, including today's, adhere to the code of conduct. Women Who Code is an inclusive community dedicated to providing an empowering experience for everyone who participates in or supports our community, regardless of gender, gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, caste, creed, political affiliation, or preferred programming language. You can read the full version and access our incident report form at womenwhocode.com/code of conduct. And we are so thrilled that we have you all for right here for Aida's talk. We have events all year round. These are some of our upcoming events in December and January. And you can find out more about our future events at womenwhocode/mobile. We would love to hear from you. So if you have any recommendations on a speaker, on a topic, or if you'd like to speak, please do reach out to us again on womenwhocode/mobile. And the best way to stay connected with us is on Slack. We are really, really active on Slack, and you can find us on LinkedIn, Twitter, Instagram, Facebook with the handle www.codemobile, and that's our QR code if you'd like to scan that. And most of our past events are available on YouTube, as well as the events from our other tracks and chapters that we have across the globe. This talk is also getting recorded and will be available on YouTube. Also, we do have a weekly newsletter. It has reminders on upcoming events, blog posts, resources, job boards. So do sign up for that and you can stay up to date with us. And before I get started, before I give it to Aida, I'd like to introduce her. So Aida is an Android engineer with over 6 years of experience building applications for various industries, ranging from cloud gaming services to satellite data communication to fintech. So it's no surprise that she's all about designing and developing efficient solutions in Kotlin. On a personal level, she's that friend who has a to-do list for the day, plans everything out and creates itineraries hour by hour for everyone. We're so excited. I'm personally very excited to learn about this because I'm very puzzled about architecture and what's the best approach. So over to you. I'll just stop sharing.
Hi, Navati. Thank you so much for introducing. So let me jump onto my slides here. Oh, so many slides open. So today we're going to be talking about most valuable architecture idea. And before we jump to it, well, something is not working here with this remote. How about now? It's working. Cool. So I am a software engineer and I get paid to build Android apps, native Android apps. So that's in a nutshell about me. When we talk about most valuable architecture idea, especially when it comes to the mobile world, we first have to look at the current state of affairs in Android app. with growing complexity of fully flashed mobile apps nowadays, when mobile apps do almost everything regular websites do, we have such a complex screens that contain so much logic, so much information, and then we have many asynchronous executions. It was a time and place back then to introduce MV something patterns in order to achieve a separation of concerns, things that visible for user, the state that user interacts, and the data manipulation that is happening on the background threads. But with this, yes, MV something patterns gave us the separation of concerns. However, it came at a price of pushing updates to the view from random places, which caused us have different states on a different levels, whether it's UI widgets themselves, where we can actually manipulate to show the visibility, or like fragments and activities, where we set the visibility of some of the UI element upon clicking on another UI element, or the view models that have completely different information, different state of the business logic that they got from the lower levels to the view that it's being sent to, or even if we go lower down to the domain and data information. And so that growing complexity of mobile apps and multiple MV something patterns introduced us to MVI. And MVI is a logical evolution of the latest MVVM pattern and can be implemented on top of existing architecture pattern, whether it's MVVM or MVP, etc. And today I will talk about the MVI paradigm, how does it apply in Android world, and because there are so many different implementations and libraries out there, today I will focus on walking through the basics of MVI and building it ourselves. Since MVI is an evolution of MVVM that lives in the presentation layer, so does MVI, which means we're going to be looking at view models and the views primarily for the MVI pattern. MVI is not a new, it's based on an old, well-known idea of the finite state machine based on the unidirectional circular flow. And with unidirectional flow, it ensures that each component doesn't break the chain and does not interact with each other. This kind of approach restricts the change in state of the system only via set of defined intentions. And any undefined intention cannot cause some sort of undesired change to our state. In this diagram, we can see unidirectional flow between view model, view, and user. Let's start from the top left side. We can see there is a reducer that receives something from the processor and then sends something to the state that being passed to the render function. And that upon render function, it is being perceived by the user, right? User can see the information. Then user interacts with that information and the interaction happens via intent. And that intent gets processed in our intent processor. And that from there, after the intent gets processed, it gets sent back to the reducer. So then the circle starts over in this example. So now let's focus on each element of this diagram in details. First, it's a state. We've heard a lot about state. Everybody talks about state, but what does state usually mean? State is everything that you see as a user on a screen. On any given screen, that's what you see. By making a state an explicit immutable object, right? Some sort of it could be sealed class if you use Kotlin, right, type, or it could be data class. By making that specifically explicit, you guarantee that system does not come to some sort of invalid state. So in MVI, now if we go back to the MVI part of things, MVI stands for model, view, intent. And so model is our state, basically. So it contains all the information that user sees. And every time when the new immutable state is created, that one gets observed by the view. When we have this kind of immutable model, it ensures thread safety. And there are like very little implementation details how different developers perceive. Some developers like to have sealed classes for state, right? Like in the LCE concept of loading content and then error, and have them as a separate subclass of the sealed class. Some people like to have it as a single data class. It is entirely up to developer, however they want, but I did find it myself, actually, I find it very helpful to have a single data class for the view state that has all the LCE information, whether it's loading, whether it's error, and all the data information coming from the lower layers, and then any kind of user modification that happens along the way. And so once we get the state, right, at some point we have a new immutable object state, that state gets observed by the view. Now we land on the view level, and the observation of the state happens via render function. The render function, again, comes to the different implementation details, but in general, render function, nothing new, nothing special. It's regular. You can treat it as a regular subscribe, where you get the view state, and then you set the values of the view state appropriately to the elements, to your UI elements, where you want to either set the visibility of the button or display the some name in some text view, and so on. So that's where the render model happens to the view in this specific case. Yep, so this is the part where rendering happens when we apply the values from our view state to our UI elements. That way we will ensure that our UI elements at any given point will have exactly same data from our view state that we have gotten from the view model. So then that way they all are up to parallel. So now next one, let's say we got the information, we have displayed, we rendered that information to the user, user saw information and decided to act on it. Fingers like swiping, clicking, any kind of interactions. So this kind of interactions usually in MVI world called intent. And because MVI follows the circle unidirectional flow, it means you should have a single reactive stream. Then therefore, every kind of intent, every kind of interaction of the user has to be transformed into stream. But in Android world, what we have a set of callbacks, set of listeners coming from the UI widgets, right? And so there is a great library, RX binding from Jake Wharton, that lets you convert every kind of UI widget click listener into the stream that you can then pass on to your view model function, or have it publish subjects separately. Like in this example, where you have the published subjects, every time something gets triggered, like some sort of set on click listener happens, you can then pass it intent via this publish subject. And then as you see here, in our bind intent function, we are passing the intents right away to the single stream. So then we don't need to manually manage, here's the life cycle of the intent subject and then life cycle of the view state stream. It all comes down, flattens down to single stream. And so intent. In the view model side of things, what does intent do? What does it imply, right? And intent, the way I see is always, intent is any kind of action, interaction, event, input, however you want to call it. It's everything that has to do with user playing around with the information or any kind of data coming in from the lower levels, from the data, from use cases, from presentations, and so on. So all of them are essentially intents. And I usually split this intents in between data intent and user intent. So it's easier for me to see what kind of intents they are referring to. But in general, having only single intent class as a sealed class, it's always easier when you're working with MVI. So in this example, I have a data class called data. It means that I'm getting some sort of data information from repositories or from use cases, and I display it right away once my view actually subscribes to the bind intent, subscribes to the view model right away, and I push that data. Or like, let's say, if user clicks on a button, I do have a button click intent right there too. So that's how actually view model perceives intents. Now we have, after we got those intents, we have a processor. Processor essentially is that's the main mechanism inside the view models. It's the function that is responsible for transforming intents, getting the intents, transforming those intents into actionable items, like calling some sort of a repository or calling some sort of a use case and so on, and then sending to the reducer. And in processing, we have, I usually split them into like 3 different types of processing, intent processing. The first intent processing is a transformation. Like, let's say when user clicks on a button, right? User clicks on a button, I debounce that one, so then user doesn't click 1,000 times because I have some sort of API call happening, right? And while API call happening, in this example, it's a throw error use case execute, right? So API call is happening. I map the response of this API call into another intent, right? And if for some reason that API call decides to fail, I will map that one into error intent, and we'll start everything, this entire stream, with the loading intent, right? And by clearly identifying each intent, transforming my button click intent into different intents on every single step of the way, I am able to I'm able to not block main thread. So then main thread now sees the loading happening, and long running operations still going to be happening in the background thread. And then now the second part is called processing intents, specifically data intents. As I mentioned, sometimes intents, like whenever you create the screen, you see the data flowing in and getting displayed right away. So those intents are usually called data intents, and they get fired right after the subscription happens. when the view subscribes to the bind intent function in this example. The idea is the same, with one exception is once this intent specifically I don't actually check the cast type. I don't check whether it's a button click intent or anything like that. I get to call the use case or some sort of repository that I have received response. I map to another intent. In this example, it's a data intent. And the same happens upon error. I will transform it to the error intent, and then I will start with a loading intent. And all this error loading and data intents are just defined classes, subclasses of my intent sealed class. And then, but sometimes there are cases when we just need to pass through the intent. We don't care what's going on. We don't want to do any kind of modifications in the processor. We want to pass through that intent directly to the reducer, where reducer does the job of reducing the intent to state. And so, for example, when we get to see a pop-up, like alert dialog or something like that, and user dismisses that alert dialog, do we need to have any sort of action on that? Like, do we need to call lower layers like use cases or repositories or anything like that? Usually nothing happens. And what we want to do is we want to pass through that intent to the reducer so that reducer can update the state right away and making sure that that dialog specifically was dismissed properly. And now it all comes down to reducer. As you saw, like from the moment when the user started interacting, the hands icon, all the way down, all the way up to the reducer, it was all about manipulation of the intents, specifically mapping and transforming intents from one type to another intent type. Now in the reducer, we transform from the intents into the state, singular. But where does reducer come in play? It comes in play in the original bind intent functions with the scan with operation from RxJava. What we can do is we can pass the initial state and we can pass a reducer. Here, reducer is passed to the scan with. And the reducer itself is just a B function that takes in previous view state, the new intent, and it's going to create a new view state. Keep in mind, and you can see here, we have a when intent, and then we cast the intents and verifying what kind of type of intent it is. If it's data, we will actually copy every information that we have from the previous state and update accordingly. That way we will return a new state, immutable new state. As you see, there is no manipulation to the original state is happening. What we do, we're just copying and then creating new object and passing through to our bind intent function scan with. And this is what unidirectional cyclic architecture means. But where's the catch? The most important catch is a high learning curve. MVI requires a knowledge of reactive programming. It also requires knowledge of multi-threading and concurrency, being able to glue all this together, being able to see everything from above and understand how it's working all together. It does require a lot of knowledge for that. And so the learning curve is high. But I do hope with today's presentation, I have lowered down a little bit that learning curve. The second one, boilerplate code setup. Yes, it does create additional classes and files, as you saw with the state and the intent. It also requires to have a reducer function, right? And then a bind intent function inside the view models. Obviously, it might create a discomfort for some people having those additional files and classes, but in general, like the more you work in MVI and then the more you keep on doing, copy pasting just becomes easier. And then like modifying stuff, like what kind of intents this screen specifically need, or what kind of values do you need in this state? Because there are different needs for different apps, right? Sometimes what you can do is you can come up with the base state and then base intents. Like for example, you would know for sure that your app will have a loading and will have some sort of dialogue to display an error. So that could be a base. And the third one is, because view state, right? When we talk about state, we discuss everything that comes to the view that user perceives and sees. It usually means that you as a developer have to handle every state, every manipulation, every interaction, like special handling of the alert states, animations, and so on. Everything has to be handled. Otherwise, you will end up in the situation where the state, if you decide to, for example, dismissing the dialogue, right? In the regular MVVM, if you click outside of the screen, outside of the dialogue gets dismissed. MVV view model does not know that dialogue got dismissed, but you don't need to care about that stuff, that dialogue got dismissed, it's all cool. But when you have an MVI, when dialogue gets dismissed and you don't handle that dismiss listener, the dismiss action, when next time when user interacts and the new state gets sent, that dialogue will pop up again. So it does require you to think more about the state as a whole, requires you to think about all these kind of edge cases, like even regular test cases. So that's where special handling comes. And another a lot of people complain about is redundant UI re-rendering, because every time like user, you display the information when the view is created, user interacts on that information, then that information gets processed with a new state, the screen gets updated, and so on with every interaction. It might cause a lot of UI re-rendering. But the truth about that stuff is nowadays what we have is a lot of our elements end up in the recycler views, right? And then recycler views come handy with a lot of diffing util tools. So that's where diff util tools from the recycler views are really good. Also, worth noting that with a lot of different libraries of MVI, they already handle this kind of diffing issues, the handling of alerts and animations and so on. The libraries already give you that ability to handle out the box. And so we have this kind of caveats, right? The usually caveats, but then we also have places where when we start developing in MVI, especially with the MVVM mindset, there are moments where we can trip over. So where we can trip over, first thing is overengineering. A lot of time, so when I started MVI, I started reading a lot of articles, a lot of information, and everywhere where I would read, it would start with, hey, here's the intent, here's the effect, here's the result, here's the action, oh, here's the state. There were so many different types and then classes, and then you have to spend time trying to glue all this together. So that's why like it gets way too complicated. And then I always tell myself personally, and I tell everyone, like when you do something, like think about from your app's perspective. Don't over-engineer stuff. Have one state that represents a view state of what you see, and have an intent, that one sealed class that you can later on, if needed, maybe grow over and then introduce effects or results or something else. But for now, just have intent. And you know exactly when you have two classes, then you can easily reduce from one type to another type. So that's the one thing that I always tell to not over-engineer stuff. The second issue is a partial state of the view. Again, comes from MVVM expertise, you know, like the MVVM way of handling, when we forget that there are some states like dismissing the dialogue, right? And then it happens that during the compiling, we get that error again. We get that dialogue again when we learn that for some reason we forgot to fire dismiss intent. Usually this gets resolved the more you practice MVI, and then the more you learn about the view as a whole image. And then there is another thing about the concurrency issue is, let's say if you have some sort of long running operations on the background thread, and then you still want to have a active UI interaction happening. Sometimes there could be moments when your state that you were expecting a couple seconds earlier comes in just now, comes in just now, like 3 seconds later, because of these concurrency issues. So one thing about this is, again, the libraries that are available for MVI handle this first in, first out paradigm out the box for you. And now talking about some good positive things about MVI. It makes debugging on the fly. It makes debugging so easy because you have a state, right? And that state is a single source of truth. All interactions and mapping from those interactions to the state is contained within a single reactive stream. You can actually have a single source of truth. And then with unidirectional flow, you also ensure that each component does not break a chain and does not interact with each other in undefined ways. And because the state is an immutable object, and then every time the new object gets passed to your view, right? It means you can easily debug and reproduce the issues. And then it has a clear sequence of the changes. Because like, let's say, as an example from the previous bind intent function, because it's a single reactive stream, what you can do is you can have do on next operation, and then log the state and then the current state and then the current intent every time. So you know exactly what state the user was in before the crash happened, and you can easily reproduce it. Another thing that really makes me like happy about the MVI is testing. Testing is made easy, and testing is made on fly. Like the testing in MVI just becomes trivial. And with unit testing, you can cover all your UI tests, all your UI states. And imagine just because you have a screenshot for each time the UI changes, right? That's your state. It means you can debug, it means you can test, you can reproduce the state issues easily. So let me show you an example of the unit testing. Like, let's say you have a button clicked. For the unit testing, I'm following regular when, given, when, then pattern. When, let's say, when I click on a button, I would like to display an error, the view state with an error. And what I do is, in a given part, I set my default view state, regular view state. I define my expected error, right? And then from there, I create an array of view states that I'm expecting. The first one to be the original view state, right? The original view state. And the second object inside my array is a new view state with an error inside. And when we bind the view model to, when we bind the view model with the intent subject, what we can do is we can fire up that intent specifically that is responsible for the button click to see what's going to happen if the button gets clicked. And then we can verify if the results expected values are equal to the expected values. With MVVM, when you actually write the test, especially if you have a complex screens, what you end up having, you end up verifying if this operation was not called, verify if this one is not called, verify if this one was specifically called, verify if this observer was not changed, right? Like if you have some sort of live data observer, you want to make sure it was not changed, and so on. So then the time to write the unit test for each test case becomes like longer and longer. And next part is coding time, to show you guys side by side how MVVM and MVI looks like on both cases. Let me see. How can I do that? I think I gotta stop sharing here. Oh, nope, wait a minute.
You probably do have to stop sharing. I think it looks like you picked, and you'll have to pick something different.
Okay.
Do you want to stop and take a quick question break before we kind of switch gears here?
Yeah.
Navati, if you want to manage our Q&A, and if everyone has any Q&A, please feel free to drop those while we kind of move from the presentation to coding.
Yeah, we do have a couple of questions here. So one is, would you recommend starting with a library or starting from scratch?
I would recommend, in order to get the idea of how MVI works in general, I would recommend having some sort of little side project and then building that side project from the scratch to get the idea of MVI on hands. Because at the end of the day, no matter how many articles you read and then how many presentations you watch, until you get your hands dirty, it's not, you won't get the concept right away. So I would recommend to have a side project, small side project, build it from the scratch, the MVI. Like the MVI is not complex, it's pretty simple. Like if you start building yourself, you'll notice how you can see the screens, the views, right? And then, but in your production app, I would recommend to use libraries that are out there, because then it will give you, you're going to be more comfortable, you understand the concept, and then you will be able to drive the library implementation easier in your production app.
And as a follow-up, like, are there any libraries that you recommend?
Oh, yes. So Mosby library from Spotify is really good. It's very popular, been adopted with many people. There is a MV Core app library exists. And what else? There were other libraries out there. There are other libraries. So like a lot of big companies have created their own libraries around the MVI as well. So that's the stuff. But like Mosby is, I guess, the most popular one and really good one. Yes, Mosby from Spotify.
Nice. And also, we has a question. in what use cases would MVI shine over MVVM? How do you decide which architecture to use in certain situations?
So MVI shines specifically in the complex screens. So one of the examples that I give is, like, imagine you have a checkout page, right? Where you have so many rows of information, like here's the milk 5 pieces, like coffee 25 pieces, and you have a stepper where you can increase, right? And then down below there, you have a row to include your payment information. It says payment, you click on it, right? You type in something, or like dialogue appears. Or like when you type in the payment information, you need to verify there's an API call happens. It's all happening within the one screen, like the one checkout. And then down there, you also have to include your delivery address. The delivery address, it means you have to search Google Maps API or some sort of API, the address API, right, to get that information. So when you have this kind of heavy, complex screens that involve different API calls, right? And then you have this like one button there. It says that when you submit button, that you track that in enabling the enabled state of that button specifically, because you have so many rows to verify, right? And then you don't want to end up in that situation where, like, for some reason your address returned error first time, right? But then your payment actually went through, and then the button actually decided to get enabled and got disabled again because something else like returned off. So you don't want to end up in this kind of situations. And that's where MVI shines, because in complex screens, like this kind of complex screens, it helps you think view state as a whole, like as a whole of what's going on exactly here and how can we manage, like, explicitly. And then most importantly, when you have this kind of complex screens, you don't end up in these situations where the crash happened or some issue happened and you cannot reproduce it. What exactly happened? How do we know whether it was an interaction happening from some custom UI widget that set the, like, enabled or disabled the row or what? So that's where MVI shines over, where you can actually control the view state in the specifically in complex screens.
I really like that example. It's really helping me visualize it. I think, yeah, those are the questions, and we could move on to the coding part.
Yes, let's move on to coding part. Okay. So
just a quick FYI, I am going to move everyone to the stage so that they can interact with you a little bit freer. We don't have to do it in the chat since we're a fairly small group. Everyone feel free to leave your cameras off if you don't want to be recorded, but this is meant to be more of a workshop portion. So feel free to shout out your questions as you have them, as we get to see the code examples also, just so everyone is ready when that happens.
Sounds good. Okay, should I screen share? Oh, right. So I'm sharing entire screen because I need to show a emulator example. So I thought a lot about, like, what kind of project I can give as an example of things being little, to show more specifically, you know, advantages and disadvantages of MVVM and MVI specifically, both of them, because if it was up to me, I can create a case for both of them because it makes sense to have both patterns. But I do feel like MVI is an evolution of what MVVM was trying to do, and then now MVI reached that moment of not only separation of concerns, but it also managing, explicitly managing the state of the view. So here's the sample app, right? In this MVVM world, let's assume that we have some sort of backend call where we get the information. Again, this is a pretty popular screen where we can not only get the information, we can also, as a users, interact with information. let's say we have a cold brew, right? That costs us $7, and then users can decide to select the count, like some sort of drop-down spinner here, right? And based on that, we can actually populate the total price of the cold brews, and then click on continue button. So in MVVM, what we have is, in order to display the information originally, right, the first part, excuse me, what we do is we expose some function called, let's call it onViewCreated, right? And then onViewCreated is responsible for getting in information from our lower layers, right? And then they usually like kind of domain layer models, and then mapping them to our UI model. Then we actually subscribe on our background thread, and then we observe on our main thread. And upon subscription, we have a live data, right? Like saying, hey, show loading, turn the show loading on, because we want to display the show loading that is happening. And after we get the results, we want to turn off show loading. And once we get the results, we have another live data that is responsible for pushing the information that we got from our lower layers to our view. And if something happens, if there's an error case happens, we have another live data that we push. We say, hey, guess what? We have an error. Can you please update our view and make it display an error? So in a nutshell, what usually happens is we end up having a, here's a mutable live data for the loading, and we have a regular live data that our view observes. And then we have the same case for our errors, where we have a mutable error live data, and then the error that our view observed. And then we have actually the UI model, the data information that we get from our lower layers, and we display to our view. And then if we go to the fragment itself, we end up in the situation where we have a lot of observers, right? We have an observer for the loading, where we actually set the visibility of our loading. We have a error live data, where we display our dialogues in this example, right? And then we display the show dialogue. And then we also have some UI model live data that we got, and we pass, we set the values of our UI widgets to our UI model information. That's what usually how MVVM works. We have this different kind of multiple live data, multiple observers that we pass it, and our UI gets updated accordingly. But then let's say if user decides to select something in our dropdown, we expose another function called, in this example, I called it position selected, right? Or like item selected. So it's responsible every time when something gets selected here, we fire up the function called position selected. And based on that, what we do is we calculate the, this is a simplified example. I said like, okay, let's calculate the total price simply by getting a value from our UI model live data and multiplying by the position. So once we get the UI, once we get that information, what we do is we update our total price live data, right? And then we also still want to make sure that our button is enabled or disabled, right? Like let's say if we're not going to select anything, we want to make sure our button is disabled. So now what we have is, now we have 4 different live data that are responsible for most of the parts of our view state, right? And then those observables, well, not observables. In this example, they're called live data, but then they're all responsible for a singular part of the view, right? And now let's assume if we are in this situation where when the view is created, right? And then this execute function is observable, decided to throw us an error at the first place, right? The first time when it emitted, it threw us an error, but then second time when it emitted, something just happened to be working in the database all of a sudden, it returns us a success, right? So in this example, we would end up in this weird situation where our error fired up an alert to the user, we see the alert, but then our items still display the information. And we end up in a situation where we have both error and then the data being displayed in the weird situation. So this kind of race conditions can happen anytime in MVVM. Like this example, for this one is a simple example of having 1, 2, 3, okay, 4 functions, right? Now imagine if you have a view model with 25, 30 functions where at any given time, at any given moment, like you can actually fire error live data or like item live data anywhere, not only tracing down the issue that you've got, like not only tracing down the issue that you want to reproduce becomes inevitably harder, it also like, it's not easy to navigate within the view model itself. Like when you have 500 lines of code, trying to understand, oh, wait a minute, where's my item live data being fired? Where did I update the information? This one becomes inevitably harder to see and manage. Now, if we go to MVI, the same screen in MVI World, same idea behind. Feature-wise, nothing changes here. And what it does is we have a fragment. Inside our fragment, we have, we subscribe to our view model, subscribe to our view model's bind intents functions. And what does it do? This bind intents function is basically an observable with the view state. And every time it returns a new view state where we subscribe to it and then set the values right away. Set the values right away. So if we go deeper into bind intents function just receives, we pass an argument of the intents themselves, right? And then we scan our initial state. In this example, initial state, it's nothing, it's just a view state with the default values inside. We scan initial state with the reducer itself. And if there is an error, we will return a view state with an error. So now if we click on a reducer is the basically function that converts our view state into the intent. And it gets fired every time when there's new intent happening. Like if user interacts on it, or if data is coming in, the intent gets transformed and then passes through to the reducer, where reducer decides to create a new state with updated information. That way it ensures that we don't have some sort of invalid state as well. And also, oops, wait a minute. All right, so, and then back to the intents part of things. As you see, this is the published subject. It's an observable stream coming from Issayeva. It could very much be any kind of reactive stream, like coroutines in use, for example, or we can decide to make it coroutines or Issayeva. So here's the interesting thing about when I mentioned one of the issues that may happen with the MVI in the beginning when building and trying to get a grasp of MVI. let's say if the dismiss, we don't dismiss it, and we decide to run the app again, right? Usually, like let's say here, we get an error dialog. The error dialog happens. And then when I dismiss it here, I can still continue working as a regular information. But if I don't handle this intent specifically, what ends up happening is this dialog keeps appearing every time when the user interacts. Okay, so this one is taking a little longer than I expected. Although this one doesn't have any kind of API calls or anything like that. It's pure data, mock data. There you go. Did it launch? Nope. Okay, it did launch. So now back to the MVI part. If we're gonna repeat the same steps, let's say I have a count here and I click on continue, I get the error and I decide to dismiss. From the UI widget alert dialog itself, it gets dismissed right away, right? But then if I decide to choose something else, like 1, I will end up getting again the same dialog saying something bad happened. And why does it happen is because upon reducer, when I actually drop down number selected, when I select the new number, I just copy the information about the value index, like, and then the total price, and if the button is enabled. But I don't necessarily care or think about the error state. So it just basically means it's just copying over every argument, every parameter that's inside the view state in a previous view state, and just updating only this necessary information. So that's where when I say MVI actually forces you to think about all the possible interactions and listeners that happens on the screen itself. Now this bind intent function is a processor, intent processor, right? It may look like as if it's intimidating, but what happens is when you break down into small chains, like in my example, I put a data intent here, and then I have here transformed intents, right? Transformed intents, it helps you to see through. It's like, okay, so I see I'm publishing, I've got the view intents. This one's usually user interactions. And now I'm actually typing, I'm checking the type of this intent specifically, whether it's a button click or back click. And based on that information, because I know it's a button click stream, what I want to do is I want to switch map. Like I want to call some sort of repository. Or in this example, I would like to navigate to somewhere. And then at the end of the day, with transformed intents, we can just merge all of them together into one single observable, into one single stream. So that's the idea behind MVI. What else would be cool to discuss? All right, so I did this one. I think that would be a cool time to ask questions, right? So with the code examples.
I was gonna say, I don't specifically have a question. I just want to say, I think it's really cool. I've been a big fan of this architecture and haven't done it with much more than silly side projects so far. It's really fun to see like a meaningful, more meaningful example of using it.
And another like big benefit of MVI because whenever you start developing and writing code in MVI, it inevitably forces you to think all these edge cases that pop up, you know, right away. You're like, oh, okay, wait a minute, what's going to happen in this example? What's going to happen? So it actually helps you to build a better product because of like this kind of cases that just happen, like all this intents that all these interactions that are not handled on time or something else. And so as I mentioned, the snapshot of the states and intents. So the cool thing is, with especially RxJava, I love RxJava. It's something that makes me happy a lot, and it's a really cool tool, like library. So like upon do on next, let's assume we have some sort of, we have a Crashlytics where we want to pass the state or information, right? And then here, let me create a object, right? Crashlytics stuff, right? And then we have a fun capture snapshot, capture state. Some sort of capture state. We can make it as a some sort of function, for example. Okay, capture state. There you go. So let's say we have I have to pass a state. So then it doesn't make sense for me not to be stated, right? Not pass a state. So let's say we have, this is the like just example. Obviously everybody has like different implementations of like Crashlytics. What you can do is you can just upon next, like capture a state and just pass it. So that way, whether it's analytics, whether it's like Crashlytics, right, or some sort of another monitoring tool that you have in your place, you can always capture. It means every time, like you can get, you know exactly the latest information, the latest intent that's happening within the latest state that the user was in before the moment of the crash. So that's where this one comes really handy, having a state.
Are you using MVI in production at your day job?
Not in the current one, but in previous one we did. We
Gotcha.
MVI.
I know that you're an Android engineer. I'm an Android engineer, but Vivi was asking in the chat that it looks like MVI is mostly an Android architecture. I was curious if you were using MVI, if your last role had both Android and iOS, and were you matching architectures?
So here's the cool information about MVI. Because it's a reactive stream, MVI also can be used in the multi-platform world. So, which is, in my previous job, to answer the question, in my previous job, we did not match the architecture patterns or anything like that. We have agreed that having different architecture decisions, architecture patterns is good. It's good decision as long as the developer's happy, whether it's Android or iOS. So that was the decision made. But also to answer, what MVI also gives you is you can build this architecture pattern in the multi-platform world, which is amazing, especially with Kotlin multi-platform that you have in place, right? You can just use it. And then as you see, like the paradigm of MVI itself, without even having libraries, somewhat easier to grasp when you have only two classes, like here's the view state, right? And then here's we have intents. That's what it is, like that's what's happening. And once you have those two classes and you work with them only per se, like idea behind is this is not only Android thing. The same paradigm can be applied in iOS world as well too. Same way can be done in iOS. I'm pretty sure there are a lot of reactive libraries, Swift, right? I know exist. maybe some others. I don't know. Navati might know better about that stuff.
Yeah, Navati made a comment here in the chat that said she's heard more Android folks talk about it. And in my personal opinion, I feel like it is because we can use it with Kotlin multi-platform, and Android engineers just seem way more excited about that than iOS engineers. So we're like all in to jump into MVI because you can use it in that multi-platform layer where we still have to convince the iOS folks that it's a great idea.
Yep, I agree on that. Plus, also, I do feel like Android folks actually have been burned a lot with so many different architecture patterns, with so many issues that happen. And plus, also, just in general, like when we talk about state, right? When you talk to web developers or iOS folks, you guys have like app state, singular state, and from there you go and then do your life for each screen. There's always some sort of state mechanism in place, right? Some sort of finite state machine in place. With Android, there's not one state, there are states. There could be like even simply UI widgets that we have, right? Like text views, edit text, they have their own internal state. Another actually side effect I forgot to mention, caveat about the MVI is compound buttons. That's the UI widget of Android, right? Compound buttons have this set on check listener, right? No matter how hard, how much you disable them, they're still gonna get enabled because you can click through this radio button and it's gonna turn on. So that kind of stuff, like when you have a raw, you set it to be clicked, but then if user decides to select that radio button and click it right on that radio button, you end up in this state where radio button itself is disabled, but for some reason it is selected. Weird state. So we have this UI widgets with their own states that things happen, right? And then we also have, as I mentioned, the view, the fragments, the activities that can easily manipulate and decide to turn off the view. Like let's say I have, here's the button name. I set the text to button. Oh, wait a minute. Oh, here. If I selected the position, I can go find my binding button and decide to turn off the visibility of my button, right? So I say, if it's visible, it's equals turn off, I said, right? So it's gonna be false. So it gives like a possibility for developers to change something, to swap something, right? And it's not easy to catch during the code reviews when you have a fragment like 300, 400 lines, and then you make one change here. What GitHub shows you, it shows you, oh, the line 65, the change was added. The information about where exactly it was added or what kind of click listener it decided to add, it's not gonna show. It's gonna show you like this information. You're like, oh, I guess looks okay. We called the position selected. We set the visibility of button to be false. Looks good, right? But then later on, you'll find out that, wait a minute, we actually updating the value to be enabled. Does it get visible? Like, okay, we set the button to be enabled, disabled, but is it even there? You're finding out later on that apparently users are not able to check out because the button is not there to begin with, right? So your company is losing money right there. With MVI, when you even review the code, right, and you see there's some kind of change happening in an unexpected place, like let's say here, where did I actually update it? On item selected. Okay, let me find that item selected. There you go. When I see something happening in my item selected and I am actually disabling the visibility, wait a minute. I'm disabling the visibility of the button. And then again, GitHub will show you only like 2-3 lines above and lower. It will show you this kind of part where the button did get, visibility of the button did get set. As a reviewer, it inevitably forces you to think, it's like, hold up, stop. why are we setting the visibility of the button here and then we're triggering an intent, right? So that's where the questions rise, and then that's where you're able to find out, wait a minute, we didn't actually set the visibility of the button upon our rendering. We decided to set the visibility of the button outside of our rendering. When we set the outside of the rendering, it might cause discrepancies in the view state, what users actually see versus what kind of view state is in view model. So that's where, even from the code reviewer perspective, having MVI just helps a lot, because like dedicated place from the fragment, right, or from any view where you set the values from your view state. So it's like insurity is in place.
That compound button comment really hit home with me. I was in a bug triage today and someone showed me a bug where 2 different radio buttons were selected. And I was like, oh, that should not be able to happen.
Yes. I know, been there, done that. It's been there, burned there too, many times. About the compound button, I honestly think, especially with MVI, the workaround I found is not using the original radio button itself. Building simple view is faster. Having your own custom radio button view, that extensive view, and all you have there is a set on click listener. That's it. That's much easier, because then you have only like, is it clicked? Is it checked? Not checked, right? That should be only one value that is available there to handle. So that's the workaround I found. MVI idea is cool, is awesome. Android views, Android widgets do come really complicated with the inner states, to manage those inner states. But guess what? Knowing MVI, like learning the MVI and going through the MVI, will help so much with migration to Jetpack Compose. That's something that I didn't mention either, because especially in Jetpack Compose world, the state itself, it's something that will get repeated over and over again, and it's something good, like start learning like through MVI what the state does, what the intent does, and then later on it's easier to migrate to Jetpack Compose from MVI, not from MVI, from the traditional Android views to the Jetpack Compose.
Do you think, probably it's not something you recommend, but do you think MVI can be implemented without some kind of reactive paradigm? Like, I mean, without a reactive library, actually, more like RX Java or something, like, can you implement it without it?
It can be implemented, but it's going to be a lot of boilerplate, far more boilerplate, because you need to care about concurrency. You still need to think about like different kind of threads that gets triggered, and then you still want to combine after they get actually like subscribed on the background threads. You still want to bring the results back to the main thread. So there is a lot of work going on. That's where the reactive libraries come handy, because they manage all that stuff behind you. Like they manage everything behind the scenes, and then it gives you like nicer way, nice interfaces like subscribe and then observe, like that will make developers' life easier. So that's the stuff.
Yeah, and like you said, it's those skills are transferable for Jetpack Compose or for us with UI. Yeah.
Definitely.
Yeah, I don't know if you have any more questions.
Any last minute burning questions? I feel like I've got it on my note. I see Vui said that the combined framework might work well with Swift UI. And I think that's absolutely true. I think that's a really comparable framework to flows on Android, and that it will. I don't want to speak too much about iOS, but I think it would work from my understanding of combined.
Same, like something that needs to check. And so this is the code part. Let's see if it's gonna go. Oh, I have also last parts of my presentation. So what does MVI give to developers? Most importantly, it gives consistency and predictability, right? And it makes debugging, testing, reproducing of crashes easier because of the view state screenshots that you can capture and send it over to your monitoring tool. And most importantly, you can finally now as a developer forget about MV something architecture patterns and instead focus your time and energy on the business logic of the app that you're building. And so that concludes the information on most valuable architecture idea in Android. Thank you very much, Navati, Sierra.
Thank you so much, Aida. I think your talk was most valuable. Yeah, thanks for prepping us for something that I think we all are going to need eventually, whether it's MVI or whether it's this whole reactive approach.
Yeah, definitely, yeah. I do feel like nowadays, especially in Android community in general, we always come up with MV something pattern name. It's like it's a tradition. MVP, MVP, MVVM, MVI, and then there will be MVIVM. You know, like,
I don't think we can get away from that MV. We're always going to need models. We're always going to need views.
Yeah, exactly. And the thing is, like, what baffles me up a lot is like I had myself personally when I was starting with Android models. Like, and now it would actually drive me crazy because I'm like, wait a minute, what models are we talking about? Wait a minute. Oh, apparently we have a data layer, has its own model there. We have a domain layer, it has its own model there. Hey, we have a presentation layer, it has its own model there. So especially when we talk about these patterns in the presentation layer, I do feel like having M there just doesn't justify. We should put it like S or like SVI. Well, something state view intent, you know. It changes something like, and it makes you think different, like more focused.
Yeah, the fact that model is different in this in MVI, I think that makes sense.
Yeah, so in MVI, model is actually state, is in everything that you see is contained in the data class.
Yeah, everyone's thanking you there. And yeah, seems like the Android developers more into MVI. Even at my place, even today during our lunch and learn session, we discussed MVI. Like the Android guys were presenting MVI. So
you got a sneak peek.
Yeah.
Thank you all so much for joining us, hanging out with us. And Ida, thank you so much for presenting. I was super excited about it. I loved it.
Thank you so much for letting me present and talk about the MVIs and like from my point of view, obviously.
The presentation recording should be available on YouTube in the next week or so. If you need a second pass at all that information. And then other than that, we just hope to see you all at our next event, our final event of the year on December 17th.
Thank you so much, Aida.
Thank you very much, Navati.
See you guys soon.
Thank you.
Thank you, Sierra.